What's up guys, Chris here from True North Math Tutoring. In this video, we're going to go through how to find the x-intercepts of a trig function. Now, in my last video, I mentioned that you can do this tech-free. You can only do this tech-free in some cases. In both of the cases that I'm going to show you in this video, you do actually have to use technology, but I'm going to show you how to do it with working out rather than just putting it in your graphics calculator. So first thing, to find the x-intercepts, like any function, we need to let y equal 0, which I've done here. And now I'm going to rearrange this so that I've got sine of something in brackets. Once I've got sine of something in brackets, in this case 2x, I'm going to let a equal to x. So now I've got this here, right? And given that the right-hand side of the equation, so the -1/4, it's a negative value, right? That means that A, the angle, must be located in the negative sign quadrants on unit circle. Unfortunately, in this video, I'm just assuming that you have a good understanding of unit circle. I might make a video on unit circle, but I'm not too sure yet. If I do make a video, it's going to be in about a week or two from now. So the next step I have to do is I'm just going to ignore the negative for a second, and I'm just going to solve 1/4 equals sine A to figure out what A is equal to. After doing that, it just so happens that A is equal to approximately 0.253. Now, using unit circle analysis, right, because we had -1/4, I want to draw my lines, right, or I want to draw my position of my angle in the quadrants that are going to be negative for sine. So that's going to be both the tan quadrant and the cos quadrant. So I've just put my angles in there, I've drawn them in, and the angle made with the horizontal has to be the same as what A was equal to before. So with unit circle, it's all about the angle made with the horizontal. We don't care about the angle made with the vertical. So I've got to find my first angle, and I've put this as theta. Technically it's A, but I've just called it theta in this case, and it makes sense that for the first angle, theta is going to be pi plus that extra 0.253, which ends up being approximately 3.39, rounded to 2 decimal places. Now I've got to find my second angle, so I've got to go all the way around from 0 to my next angle, which is going to just be 2 pi minus 0.253, because I've nearly done a full revolution, but I'm short by 0.253 radians. So that equals approximately 6.03. Now what I want to do, I want to substitute A equals 2x back in, and then I just want to solve for x, right? Because x is what we're looking for. So when I do that for the first situation, x is going to be just whatever the angle was divided by 2, which is 1.695 for the first and 3.015 for the second. So that means that on my graph here, I've just found the two x-intercepts. I did go and check this. There was, I think, a slight error due to rounding, but it was pretty much spot on. All right, so this one was a little bit more complicated. We've got a trig function, and what I didn't do in my last video, I didn't find the y-intercept in this case. So let's start with finding the y-intercept first. So what I've got to do to find the y-intercept, obviously I have to let x equal 0, which I've gone and done. That leaves me with 3 times by cos negative pi on 2. I'd have to evaluate negative pi on 2 without a calculator. So using a bit of unit circle analysis, or because it's a multiple of pi on 2, I like to just think of it as looking at a cos graph. Going backwards, we can see that at negative pi on 2, cos is equal to 0. So that means that when we substitute that in, the y value or the y-intercept is going to be -2. Therefore, y-intercept at y equals -2. Obviously, this graph is not to scale. Okay, let's talk about the x-intercepts. So to calculate the x-intercepts, we're going to do a similar approach to what we did before. I've got to let y equal 0 and do some rearranging. Now what I'm going to do once again, now that I've got cos with something in the brackets, I'm going to let that whole thing in the bracket equal a. So now I'm going to just solve 2/3 equals cos a by moving cos over to the other side, making it inverse cos or arc cos, and then now that gives me a value of approximately 0.841. And I've just put that on my unit circle because we didn't have any negative values and we were dealing with cos. That means that the all quadrant and the cos quadrant are going to be used in this case. So theta, or A I should say, is therefore 0.841, or it's just going to be 2 pi take away 0.841, which is approximately 5.44, rounded to 2 decimal place. Now what I'm going to do, like I did before, I'm going to substitute A back in, and I'm going to solve for X. And just before I do that, what I've gone and done here, I've just gone and made X the subject first, and then now I'm just going to substitute both angles in for A. So once I do that, that's what I get, and then solving both of those with a calculator, those are the x-intercepts that I find. Now notice I've found 2 x-intercepts, however, we still need to find this x-intercept that's just after the y-axis. We haven't found that one yet. Now what we can do though is, given that the period of this function we worked out earlier, the period is 2 pi. Oh, sorry, not 2 pi. The period is pi on 2. So what I can do is, because this graph is going to repeat itself every pi on 2, I can just subtract pi on 2 from 1.752, and that will give me the value of that first x-intercept right at the beginning. So when I do that, I get approximately 0.181, and then that is my value. All of those I checked on Desmos. There was a couple of small, very minute rounding errors, but the x-intercepts were pretty much spot on.